in the deepest quiet of the forest floor, where sunlight fractures into thin green threads. Life moves with a precision so sharp it borders on the impossible. Here, every shift of air is measured, every vibration is interpreted, and every shadow holds a hidden intention. Snakes glide with ancient confidence, built to dominate entire ecosystems. Yet in this microcosm, an unexpected force reshapes the meaning of danger. A small predator waits among the leaves, still as carved stone, armed with reflexes that rewrite the rules of survival. This is the realm where power is not measured by size, but by precision. The Amazon rainforest is often imagined as a kingdom ruled by giants. Jaguars patrol the understory, harpy eagles dominate the canopy, and anacondas coil through blackwater swamps like drifting shadows of muscle and ancient instinct. Yet beneath these towering rulers exists another world, one so small and intricate that most eyes never notice it. It is a universe measured not in meters, but in centimeters, where the laws of motion change and evolution write strategies invisible to the human scale. This is the world where the praying mantis lives, hunts, calculates, and survives with a precision unmatched by creatures many times its size. While the rainforest above pulses with dramatic encounters between apex predators, the true mechanics of nature's intelligence unfold at ground level. This is where leaves become shelters, twigs become lookouts, and a single drop of water can magnify the world like a lens. Snakes occasionally enter this domain, especially the young ones, and when they do, their mastery of movement is challenged by forces they were never designed to overcome. Snakes are icons of stealth. Their bodies calculate angles and surfaces with astonishing accuracy. Their movement is silent, fluid, and deliberate, but the micro-world operates under a different tempo. Here, the speed of life is compressed. Reflexes are faster. Perception is sharper. Threats appear and disappear in the blink of an eye. A serpent evolved for macro-scale dominance enters this world as a stranger. Its senses, perfectly tuned for mice, frogs, and birds, become slower and less effective when facing creatures engineered for explosive, instantaneous reactions. This mismatch creates an unexpected balance. Not a rivalry, not a battle, but a delicate tension between two evolutionary masterpieces that rarely cross paths, yet influence each other's design across millennia. The praying mantis is a being shaped by meticulous natural engineering. It stands motionless, as if time has paused around it. Its forelegs are folded like blades waiting for a signal that only it can detect. Its head rotates with uncanny independence, scanning the environment with vision that rivals that of small vertebrates. While snakes read the world through tongue flicks and heat signatures, the mantis reads it through triangulation and depth analysis. Its eyes do not just see shapes, they calculate exact distances. Its brain does not just interpret movement, it predicts it. In a world of centimeters, prediction is survival. For a young snake, this world presents challenges that evolutionary history did not fully prepare it for. Its movements are graceful but comparatively slow in this dimension. Its reliance on vibration and infrared cues gives it reliable information about rodents and amphibians, but is less effective against a creature that can remain perfectly still for minutes, sometimes hours. This mismatch creates an illusion. To the snake, the mantis seems harmless, a fragile insect among thousands. But under the microscope of ecological truth, the mantis is one of the most specialized ambush predators on Earth. Its strike speed can exceed the reaction time of many small reptiles, not because it is stronger, but because its entire physiology is optimized for the microsecond scale. The strategy is simple. Remain invisible until the exact moment where invisibility becomes power. Then unleash motion so sudden that the prey's nervous system barely registers it. While this film does not tell a story of conflict or conquest, it reveals something more profound. Nature is not built on hierarchy, but on balance. Each creature occupies a niche that defines the rules of its evolution. Snakes are architects of controlled movement, sculpted by millions of years to navigate large ecosystems with silent authority. The praying mantis, on the other hand, is designed for an ecosystem so small and dense that each leaf becomes a battleground of hidden strategies. When their worlds overlap, the result is not a fight, but a rare moment of evolutionary contrast. The mantis, with its lightning-fast calculation, represents precision. The young snake, still learning the patterns of survival, represents vulnerability. Around them, the forest continues its symphony of growth and decay, unaware of the subtle tension unfolding in its smallest corridors. The ground beneath the forest canopy is a living maze. Twigs, fallen bark, and tangled roots form an architecture of complexity that challenges even the most agile creatures. This environment is the crucible where micropredators thrive. Every centimeter is a vantage point. Every leaf casts a shadow that can conceal predator or prey. In this dimension, the praying mantis becomes an apex strategist. It blends seamlessly into this mosaic, its body mimicking the texture of vegetation, its movements measured and careful. Snakes, especially juveniles, pass through these spaces as apprentices of survival. Their senses are powerful, but not perfect. Their muscles are strong, but not yet fully coordinated. They navigate by instinct, avoiding movements they cannot interpret and freezing when the unknown emerges. The micro-world is governed by a fundamental rule. Specialization dominates strength. The mantis embodies this rule. It has no venom, no massive muscles, no ability to constrict. Instead, it has precision. It has calculated patience. It has eyes that see in 3 dimensions and arms engineered to snap shut with mechanical reliability. A juvenile snake brings its own evolutionary toolkit: camouflage, flexibility, and caution. But against the mantis, its advantages diminish, not because the mantis is superior in power, but because it operates on a scale the snake rarely encounters. The two creatures are separated by a chasm of ecological logic, yet they share a deeper connection. Both are products of pressures that sculpt beings into perfect machines of survival. As the camera descends into this miniature universe, the forest seems to breathe differently. The air is thicker with detail. The movements are sharper. The stakes are higher, not because the creatures are large, but because their world is fragile. This is nature reduced to its purest form, survival written in millimeters and milliseconds. In this hidden realm, the praying mantis becomes a guardian of equilibrium. Its presence keeps populations of small animals balanced. Its movements shape the behavior of countless organisms, including snakes. And while adult snakes rarely encounter mantises, young ones remember the speed of this world. They learn to avoid sudden bursts of movement. They learn to respect what they cannot track. Every encounter in the forest, no matter how small, contributes to the architecture of life. The mantis teaches the lesson of precision. The snake teaches the lesson of adaptation. Together, they reveal a truth that defines the rainforest. Power does not belong to the largest. It belongs to the best designed. And in the micro-realm, design takes the form of speed, stealth, and an intelligence carved by millions of years of silent evolution. Here, at the border between two evolutionary worlds, a new perspective emerges. A perspective that sees beauty not in scale but in detail. A perspective that understands that survival is a universal language spoken differently by every creature. The rainforest floor is often described as dark, humid, and silent, but silence is an illusion. Beneath the broad canopy, where only fragments of sunlight survive the descent, the ground vibrates with constant activity. This is the domain where insects, amphibians, and small reptiles coexist in a tightly compressed ecological stage, one so intricate that each step contains more life than the average human sees in a lifetime. To understand why a creature as small as a praying mantis can influence the behavior of young snakes, we must descend into this miniature world. Here, the scale of existence shrinks, yet the complexity increases. A fallen leaf becomes a ceiling. A pebble becomes a cliff. A tangle of roots acts as a labyrinth that governs the movement of every organism passing through it. In this realm, survival is determined not by size or brute force, but by specialization. Every creature is an expert in its own microscopic niche. While the larger rainforest showcases scenes of jaguars, stalking capybaras, or anacondas drifting through flooded forests, the real architecture of nature's balance begins far below, between grains of soil and decomposing wood. Every beetle, every ant, every tiny reptile participates in a system designed to recycle life endlessly. Each action, however small, echoes across the entire ecosystem. A micropredator, like the praying mantis, thrives here because the environment rewards precision. The forest floor is unpredictable. Shadows break and reform with every sway of the canopy. Moisture coats surfaces, muting vibrations and altering how sound travels. The ground is layered with organic debris, each layer teeming with potential prey or hidden threats. In this dense confusion, clarity becomes a weapon, and speed becomes security. The mantis embodies both. It stands completely motionless, camouflaged within the tapestry of browns and greens. Its shape mimics the jagged outline of leaves or slender stems. To an untrained eye, it vanishes into its surroundings. To a young snake, it becomes part of the landscape, a feature rather than a being. Snakes entering this micro-ecosystem face challenges unfamiliar to their evolutionary design. Their senses, refined for detecting larger prey or predators, encounter stimuli too subtle or too fast to accurately interpret. The flick of a tongue captures chemical traces, but the chemical world here is crowded with signals overlapping and dissolving into one another. Heat signatures blur against the warm soil. Vibrations dissipate quickly in the soft debris. Vision, adapted for low-light conditions, but not for rapid micromovements, reveals shapes without revealing their intentions. For a juvenile snake, the ground becomes a puzzle of meanings that must be solved to avoid danger. This is why the microworld shapes their early behavior. They learn to move carefully, to pause frequently, to rely on stillness as both shield and strategy. They do not fear the mantis specifically. They fear the unpredictability of everything that lives at this scale. Evolution treats small creatures differently. While large predators can afford the luxury of slower reactions and broader territories, micropredators must compress their entire survival strategy into bursts of perfect motion. Ants coordinate like living machines. Spiders build architectural traps in miniature. Beetles produce chemical defenses powerful enough to repel attackers many times their size. And the praying mantis stands among them as a pinnacle of precision. Its hunting perch may be only a few centimeters above the soil, but from that vantage point, the world becomes a field of opportunities. It watches the subtle waves of movement caused by passing insects. It measures distance with binocular accuracy. It waits until the probability of success reaches near certainty. In the micro realm, mistakes are costly. A single failed strike can mean starvation. A single misjudgment can turn hunter into prey. This pressure sculpts creatures into specialists. The forest floor itself contributes to this specialization. It is a constantly shifting landscape, reshaped by rainfall, wind, and the decay of organic matter. Microhabitats form and disappear within hours. A hollow under a fallen log might shelter dozens of species during the night, only to collapse under morning humidity. Pools of water gather and evaporate, hosting temporary communities of larvae and amphibians. Fungi blossom and wither in silence, recycling nutrients and altering the chemistry of the soil. In this unpredictable environment, adaptation must be rapid. Creatures that thrive here develop strategies, not just for survival, but for flexibility, for anticipating change before it arrives. For snakes, especially the young ones just beginning their journey, the forest floor is both a cradle and a training ground. Their first lessons come not from dramatic encounters with larger predators, but from navigating the subtleties of this microscopic world. They learn patterns invisible to us. The way air shifts when an insect jumps, the faint tremor of a beetle's movement, the smell of disturbed soil left by foraging ants. Their instincts sharpen against the backdrop of constant micro-interactions. This world does not favor recklessness. It favors caution. Snakes evolve patience long before they evolve power. One of the most fascinating aspects of this microecosystem is how energy flows through it. Leaves fall and decompose, feeding fungi and bacteria. These organisms support insects, which in turn support predators like the mantis. Young snakes feed on small amphibians or insects, linking the micro-world to the larger food web. Predators from above, such as birds or large reptiles, rely indirectly on the energy processed here. Even the giants of the rainforest depend on the health of this miniature realm. Without the microecosystem constantly converting organic matter into nutrients, the entire forest would collapse. Every towering tree, every apex predator, every complex food chain rests on the tiny shoulders of creatures living mere centimeters above the earth. This realization changes how we interpret power in the natural world. Power does not always move downward from the strong to the weak. It also rises upward from the smallest mechanisms of life. The mantis, though tiny compared to a snake, exerts influence through its role in maintaining balance. Its predation shapes insect populations. Its presence alters the behavior of other microcreatures. And indirectly, its existence affects how young snakes move, where they travel, what risks they avoid, and how they perceive the forest in their earliest days. Evolution is not driven only by dramatic confrontations, but by subtle pressures repeated over millions of years. As we observe this microrealm, we begin to understand that nature's intelligence is not limited to the creatures that appear most formidable.
Intelligence is distributed across scales. It exists in the mantis's ability to judge distance with mathematical precision. It exists in the snake's capacity to interpret vibrations through the ground. It exists in the interactions between species that never develop into open conflict but still shape each other as design. The microworld is the birthplace of strategies, the cradle of innovation, and the foundation of ecosystems so vast that they seem unrelated. But everything begins here, in the stillness between leaves, in the shadows beneath roots, in the hidden corridors where evolution has been practicing for millions of years. The praying mantis stands as one of evolution's most intricate masterpieces, a creature shaped not by strength or venom, but by perfect precision. To understand its biology is to understand how nature engineers efficiency at its purest scale. While many insects rely on overwhelming numbers or chemical defenses, the mantis relies on something much rarer: control over motion so absolute that it seems almost intentional, almost thoughtful, as if each of its movements follows a formula written into the rhythm of the forest. Its body is a living fusion of geometry and adaptation. The triangular head, perched on a flexible neck, rotates with a range surpassing that of most reptiles. This ability grants it a full hemisphere of vision without shifting its position, a crucial advantage in a world where movement equals exposure. Its eyes, large, dark, and deep, reflect more than light. They compute, they analyze. They anchor the mantis to the surrounding environment with a sense of spatial awareness that borders on the uncanny. Through these eyes, the forest floor becomes a three-dimensional map where distances are not guessed, but measured with mathematical accuracy. This kind of stereoscopic depth perception is extremely rare among insects, yet the mantis wields it with the precision of a natural engineer. Its attention is selective, allowing it to ignore irrelevant motion while locking onto the slightest tremor that signifies opportunity. It does not waste energy. It does not strike prematurely. It acts only when the numbers align. The signature feature of the mantis is its pair of raptorial forelegs, tools sculpted over millions of years for one purpose: to transform potential energy into instantaneous capture. These arms fold like pocket knives, held close to the body until the perfect moment presents itself. When they unfold, they do so with an explosive force powered by elastic structures inside the joints. These structures store tension over long periods, allowing the mantis to release a burst of motion faster than many vertebrate predators can perceive. While a snake relies on coordinated muscle contractions to strike, the mantis relies on pure mechanical release. The difference lies in scale. A snake's strike is powerful, elegant, and effective in its world. A mantis's strike is instantaneous, surgical, and decisive in the micro-world. This contrast reveals how evolution shapes predators according to the physics of their environment. At small scales, air resistance, friction, and inertia behave differently. Reflexes must be faster, motions must be shorter, and strategies must revolve around absolute precision. The mantis is a perfect expression of these rules. Its behavior follows a pattern of stillness punctuated by sudden activity. The stillness is not passive. It is a strategic reset that allows the mantis to watch, think, and model its next move. In this state, it blends into the vegetation, its body mimicking leaves, stems, or bark depending on the species. This camouflage is not merely visual, it is behavioral. A mantis knows how to sway gently with the wind, how to adjust its posture so its silhouette disappears, how to remain undetected even by creatures with complex sensory systems. When it moves, the movement is measured. When it waits, the waiting is purposeful. This rhythm of observation and execution positions the mantis not just as a hunter, but as a strategist. Evolution has sculpted it into a creature that thrives in the narrow margins where timing determines everything. Curiously, the mantis also displays adaptations that feel almost otherworldly. Its eyes change appearance depending on light levels, revealing a dark pseudopole that follows the observer. This phenomenon occurs because its compound eyes absorb light in highly specific ways, making the mantis seem aware, attentive, and intelligent. Its head, capable of rotating nearly 180 degrees, allows it to track movement behind or beside it without altering its stance. These abilities create the illusion of thoughtfulness, but in truth, they are the products of fine evolutionary tuning, where each trait supports the mantis's role as a microscale ambush predator. Even its territorial behavior reflects its precision-based lifestyle. A mantis does not wander aimlessly. It selects a territory rich in prey pathways and defends it through posture, choosing the most efficient vantage points in its environment. This insect-esque design reveals an evolutionary truth often overshadowed by the grandeur of larger predators. Specialization can surpass raw strength. The mantis is not the strongest, but it is one of the most perfectly adapted creatures in the microecosystem. Its reliance on accuracy rather than force demonstrates how evolution can produce excellence without scale. And when a small snake crosses paths with a mantis, this contrast becomes evident. The snake's movements, graceful but slower on the microscale, meet the mantis's refined mastery of timing. Yet their interaction is not one of predation, but of recognition. The snake perceives the mantis as something unpredictable, something too fast for its senses to decode. This perception is enough to shape behavior, enough to guide the young serpent away from risks it cannot interpret. The mantis, unaware of the effect it has on a world much larger than itself, continues its routine, standing motionless, calculating, preparing for the next strike that will unfold with incomparable precision. To explore the mantis further is to explore the mathematics of motion written into living form. Everything about its anatomy seems designed to measure, calibrate, and execute with near robotic efficiency. Its forelegs are lined with sharp spines, arranged not randomly, but at angles optimized to secure prey instantly upon contact. These spines interlock around the target like a biological trap, preventing escape even from insects capable of powerful bursts of energy. This structural design ensures that once the mantis makes contact, the capture is nearly guaranteed. In the micro world, certainty is evolution's greatest prize. The mantis wins that prize repeatedly by converting geometric perfection into survival. Even the muscles controlling the raptorial limbs reflect this perfection. While they appear delicate, they act like tension cables capable of rapid contraction. The mantis prepares its strike by gradually increasing internal pressure, using specialized tendon-like structures to store energy. When the moment arrives, this energy is released in a fraction of a second. What would be a slow, deliberate motion for a larger animal becomes instantaneous here, defying expectation and rewriting the boundaries of what a small predator can do. This speed gives the mantis access to prey that other insects cannot reliably catch. Flies, agile and unpredictable, fall victim to this engineered motion. Crickets, despite their powerful legs, fail to react in time. Even small lizards, if they wander into the mantis's range, may find themselves overwhelmed not by force but by surprise. The mantis's brain, though small, is a marvel of efficient processing. It does not require complex cognition to perform its tasks. Instead, it relies on reflex pathways optimized through millions of years of selective pressure. These pathways allow it to make split-second decisions while conserving energy. A mantis does not contemplate, it calculates. It does not hesitate, it waits. And when the window of opportunity appears, it acts with flawless execution. Its entire worldview is built on contrast, stillness followed by action, observation followed by precision. This behavioral rhythm mirrors the movements of the forest itself, where moments of absolute quiet are interrupted by sudden bursts of life. The mantis fits seamlessly into this pattern, becoming a natural extension of the ecosystem's pulse. Another fascinating aspect of the mantis is its ability to perceive movement that other animals overlook. Its visual system excels at detecting motion against still backgrounds, allowing it to identify prey even when the prey is partially hidden. But even more impressive, its capacity to filter out irrelevant information. A mantis does not react to every wrestle or shift. It reacts only to stimuli that align with its internal targeting system. This selectivity prevents wasted energy and reduces risk. It sees only what matters. This trait gives it an advantage in environments cluttered with visual noise, such as the rainforest floor, where overlapping textures and shadows can confuse less specialized predators. A surprising detail lies in its attention-like behavior. The mantis can focus its gaze on a single object and follow it through space with uncanny accuracy. Its head tilts, its eyes adjust, and its forelegs prepare, forming a triangle of perfect calculation. This level of visual tracking is rare among insects and demonstrates the sophistication of the mantis's predatory design. While a young snake explores its surroundings through chemical cues and subtle vibrations, the mantis operates almost entirely through sight. It lives inside a visual universe that snakes can barely comprehend. This sensory imbalance creates moments of evolutionary intrigue. The snake may not understand the mantis, but it senses the presence of something uncannily fast. The mantis, meanwhile, registers the snake as a slow-moving form within a larger world that does not concern it unless it comes too close. Territoriality also shapes the mantis's interactions. Each individual selects a hunting zone where prey density is high. It does not roam widely because its success depends on familiarity with its chosen microhabitat. It memorizes angles, distances, and surfaces. It learns which leaves cast stable shadows and which pathways prey frequently travel. In many ways, the mantis becomes a living sentinel, an unblinking observer of its environment. This territorial confidence adds to its aura of control. The mantis is not reactive, it is prepared. Despite its lethal efficiency as a hunter, the mantis presents no threat to adult snakes. Its world is too small, its reach too limited, its biology too specialized for anything beyond creatures of similar scale. Yet it holds a unique position in the early life of many reptiles. A young snake crossing a mantis's territory is exposed to precision unlike anything it encounters from larger animals. This exposure teaches the snake caution. It teaches respect for unpredictable movements. It teaches the value of stillness. The mantis becomes an accidental manner of survival, shaping behavior without intention. In many ways, the mantis is a reminder of nature's hidden truths. That power manifests in many forms, that dominance is not always visible, that the smallest creatures can alter the behavior of larger ones through nothing more than refined design. The praying mantis stands as proof that evolution values elegance much as strength, and that survival often belongs to those who perfect their scale rather than aspire to another. Through its eyes, the forest becomes a calculated world of angles and opportunities. Through its movements, the forest reveals the beauty of precision, and through its existence, we witness how even the smallest predator becomes a quiet guardian of ecological balance. A young snake enters the world with none of the confidence or authority that defines its adult form. In the early stages of life, it is a small, fragile creature navigating a world far larger and more complicated than its instincts can yet comprehend. Its body, though exquisitely designed by evolution, is not fully prepared for the demands of the forest floor. Muscles are weaker, reflexes are slower, and senses, while present, are still inexperienced. Every movement requires caution. Every vibration carries meaning. Every shadow poses a question that must be answered through survival rather than knowledge. Unlike mammals, reptiles receive no guidance from parents. A newborn snake is alone from the moment it breaks free from its egg or from its mother's body. Its survival depends entirely on the efficiency of its instincts and the choices it makes within the first hours of life. These choices shape its future. They determine whether the snake will grow into a master of stealth or become another silent statistic in the forest's continual cycle of life and death. During its first days, the young snake's primary challenge is vulnerability. Its size places it within reach of countless micropredators, animals too small to threaten an adult snake, but perfectly capable of overwhelming a newborn. Birds, frogs, lizards, spiders, ants, and even insects equipped with specialized predatory traits represent potential threats. The praying mantis is one of these threats, not because it seeks out snakes, but because its strike is fast enough to exploit the weakness of a hatchling. To the snake, the mantis is not a nemesis, it is a signal, a warning written into the behavior of the micro-world, a reminder that in these early stages, the rules of survival are different. The snake must learn to move without disturbing the ground, to disappear into leaf litter, to freeze at the slightest sign of danger. These lessons are essential. They form the foundation of survival strategies that the snake will carry into adulthood. The young snake's anatomy reflects this period of adaptation. Its muscles, though capable, lack the power required for rapid escape. Its jaw strength is undeveloped, limiting the size and type of prey it can consume. Its venom, if it belongs to a venomous species, is often less potent or less controlled. Its camouflage, however, is its greatest advantage. Many newborn snakes possess patterns more fragmented and irregular than those of adults. These patterns break the outline of their bodies against the chaotic textures of the forest floor. Camouflage is not merely a passive defense. It is a biological relationship with the environment. The young snake becomes part of the substrate, part of the debris, part of the rhythm of stillness that governs the micro-world. When a mantis scans the ground for movement, it may pass over a young snake without noticing it. Stillness becomes the hatchling's first language. But survival also depends on movement, the right kind of movement. Young snakes must learn when to glide forward and when to remain still. This learning process is not conscious. It emerges from trial, error, and instinctive calibration. The forest floor is full of cues: the tremble of an insect's step, the faint ripple of air caused by a passing beetle, the irregular pattern of a spider's stride. A hatchling learns to interpret these cues not through logic but through repetition. It becomes attuned to its surroundings in a way that adults often forget. The micro-world imprints itself on its senses, teaching the young snake how to survive in an environment where every mistake is amplified by its small size. Food is another significant challenge. A young snake must identify prey small enough to swallow, abundant enough to sustain growth. Tiny amphibians, insect larvae, and soft-bodied invertebrates become essential resources. The act of feeding is a lesson in itself. The hatchling must learn how to position its jaw, how to secure prey without alerting nearby predators, how to navigate the delicate balance between hunger and caution. Over time, the snake's movements become more fluid, its senses sharper, its instincts more reliable. It begins to understand its body, the mechanics of its muscles, the reach of its strikes, and the meaning of the forest's subtle vibrations. Predators of similar scale teach the young snake essential lessons. The praying mantis, for example, introduces the snake to the concept of impossible speed. A mantis's attack occurs faster than the snake's nervous system can respond. For a hatchling, witnessing such speed, even from a safe distance, reshapes its understanding of danger. It learns that not all threats are large, some are invisible until the precise moment they act. This awareness drives the snake to adopt more cautious behaviors. It becomes sensitive to sudden shifts in the air, to small movements, that break the stillness of the leaves, to the presence of creatures whose patterns do not match the predictable rhythm of the forest. These experiences create an internal map of risk. The young snake avoids areas where micropredators gather, selecting routes with fewer disturbances, fewer hiding spots for creatures capable of rapid ambush. In this stage of life, the young snake is defined not by strength but by adaptability. Its greatest evolutionary asset is its capacity to learn quickly from its surroundings. Unlike mammals, which rely on social learning, snakes rely on sensory refinement. The more time they spend navigating the micro-world, the better they understand the invisible architecture of danger and opportunity. They memorize the textures of safe ground, the acoustics of certain substrates, the patterns of light and shadow that conceal predators. They learn that some insects are harmless while others, like the mantis, command respect through their unpredictability. This gradual accumulation of knowledge forms the groundwork for the snake's future dominance in the macro world. As the snake grows, its body begins to shift toward the design that makes adults such successful predators. Muscles develop density and strength. Reflexes become sharper. The jaw becomes capable of manipulating larger prey. Venom, if present, becomes more potent and more efficiently delivered. But even as the snake gains size and confidence, the lessons learned in the micro-world remain deeply embedded. The forest floor becomes easier to navigate, not because it changes, but because the snake changes. It no longer fears the unpredictable movements of micropredators, yet it retains an instinctive caution that prevents reckless behavior. In adulthood, a snake may dominate small mammals, amphibians, or birds, but its earliest memories tie it to the delicate world where it once moved among leaves, roots, and insects as a vulnerable creature dependent on silence and precision. In many ways, the journey of a young snake mirrors the evolution of reptiles as a group. Success comes not from overwhelming strength, but from the ability to adapt to environments of all scales. From the micro-world of hatchlings to the macro-world of adults, snakes navigate a continuum of ecological challenges. This adaptability is what allowed snakes to survive mass extinctions, colonize diverse ecosystems, and thrive across continents. And at the heart of this adaptability, the earliest stage of life, where a small, fragile creature learns that survival begins with understanding the smallest movements, the smallest vibrations, and the smallest predators. What makes the praying mantis significant in this story is not that it hunts snakes, but that it represents the micro-world's most extreme qualities: precision, speed, unpredictability. These traits shape the early lives of countless creatures, including snakes. They introduce young reptiles to the fundamental truth of the forest: danger does not scale with size. A creature smaller than a leaf can teach lessons that echo into adulthood. A predator weighing only a few grams can influence the behavior of animals hundreds of times larger. In the rainforest, survival is a dialogue between organisms of every scale. For the young snake, the micro-world is not merely a habitat. It is a crucible. Each experience here refines its instincts. Each encounter shapes its evolution. The mantis stands as one of the many sculptors in this hidden realm, its presence an instrument in the orchestra of natural selection. And long before the snake becomes a symbol of silent power, it is a student in a world ruled by creatures that measure their lives in milliseconds and millimeters. Evolution does not unfold as a single storyline, but as countless parallel narratives shaping one another across millions of years. Insects and reptiles are two of nature's oldest survivors, each carrying adaptations refined through eras of instability, climate shifts, and ecological upheavals. Though they inhabit different scales of existence, their evolutionary histories intersect in subtle yet profound ways. When a praying mantis and a young snake cross paths, what appears to be a simple encounter is actually the meeting of two ancient strategies forged by completely different pressures. Their interaction is not defined by conflict, but by contrast. It reveals how evolution sculpts life to fit every corner of the natural world, from the smallest spaces between leaves to the broad landscapes ruled by apex predators. Insects emerged long before reptiles, colonizing Earth when the planet was still raw and unstable. Their bodies were shaped by a world where size offered no advantage. Instead, the insects that thrived were those that developed speed, sensitivity, and specialization. Over time, their nervous systems became some of the fastest on the planet, capable of processing stimuli with astonishing precision. Their limbs evolved into tools for grasping, jumping, flying, and evading. Their eyes developed complex lenses that could detect even the slightest motion. These adaptations allowed insects to dominate the microworld long before reptiles appeared. They became the architects of an ecological universe defined by milliseconds and millimeters. Reptiles entered the scene much later, in a world reshaped by the success of these early micro-creatures. From their beginnings, reptiles were forced to adapt not just to larger predators and environmental changes, but also to the abundance and unpredictability of insects. Their evolution reflects this challenge. They developed lungs capable of sustaining long periods of stillness, muscles that could coil and release with quiet efficiency, and sensory systems that could interpret the faintest chemical trails. Reptiles learned to survive in an environment already mastered by insects. This dynamic set the stage for a silent evolutionary dialogue. Insects pushed the boundaries of speed and precision, while reptiles responded by refining stealth, patience, and sensory perception. The praying mantis embodies the pinnacle of insect specialization. It is not simply a predator, it is the product of an evolutionary experiment in accuracy. Its raptorial arms, stereoscopic eyes, and lightning-fast reflexes allow it to command authority within a few centimeters of space. In contrast, a snake, even a tiny one, carries adaptations built for a completely different world. Snakes evolve to interact with prey that navigates through the forest's broader structures: frogs, rodents, lizards, and birds. Their anatomy excels at silent approach and decisive strikes. But when a snake enters the micro-world, it encounters physics that its body was not built to negotiate. Air resistance, friction, and motion behave differently at small scales. Instincts that work seamlessly in the macro-world become less reliable here. Coevolution does not require frequent interactions. It requires consistent pressure across time. Insects, with their extreme adaptations, have indirectly influenced reptile evolution by creating environments filled with unpredictable micromovements. Snakes learn to avoid rapid shifts in the undergrowth because these movements often signal potential danger. They learn to freeze when confronted with patterns they cannot decode. Over generations, these lessons became etched into their behavior. Even species that never directly interact with mantises retain caution toward sudden, microscale motions. This is the invisible architecture of evolution, traits shaped by encounters so rare we may never witness them, yet persistent enough to leave genetic footprints. The balance between insects and reptiles is not a struggle for dominance. It is a dynamic equilibrium. Insects process organic matter, pollinate plants, and sustain ecosystems from the ground up. Reptiles regulate populations of amphibians, rodents, and other small creatures. Their roles complement one another, forming a loop that maintains the health of the forest. But the relationship also includes moments of tension. A small snake may become prey for a larger insect. A reptile may consume insects to survive its early days. This interplay of roles ensures that no single species overwhelms the system. Evolution thrives on such checks and balances. One of the most fascinating aspects of this cross-evolution is the transfer of fear, not through individual experience, but through instinct. A young snake that freezes when a mantis shifts its posture is responding to a biological memory shaped over millions of years. It inherits caution encoded in its nervous system, refined by countless generations of ancestors who survived because they respected the unpredictable speed of certain insects. That inherited caution is not fear in the emotional sense. It is an evolutionary algorithm. It tells the snake, if movement is too fast to interpret, Do not attempt to confront it. If the signal is unclear, stay still. This instinct allows snakes to navigate a world where many dangers cannot be fought, only avoided. For insects, the presence of reptiles also shapes behavior. Many mantises adopt camouflage patterns that deter reptiles by making them appear less attractive or more difficult to detect. Some species mimic thorns, petals, or dead leaves. These disguises reduce the likelihood of being eaten by reptiles or birds. Insects with faster reflexes are more likely to evade the sweeping tongue of a lizard or the probing strike of a snake. Over time, these traits spread through populations. The pressure created by reptilian predators becomes part of the mantis's evolutionary story, encouraging the development of traits that enhance survival. The result of this long evolutionary interplay is a complex tapestry where insects and reptiles share strategies without ever directly influencing each other through conscious behavior. The mantis learns nothing from the snake. The snake learns nothing from the mantis, yet evolution teaches both. Their adaptations reflect a silent communication across epochs. In the mantis, we see the extreme refinement of precision. In the snake, we see the refinement of avoidance, stealth, and sensory interpretation. Both organisms mirror the pressures of the environments they inhabit, shaped not by each other directly, but by the shared challenges of survival. Cross-evolution is most visible in the rare interactions between young snakes and mantises. In these encounters, the snake often hesitates, not because the mantis is a dominant predator, but because the snake recognizes unpredictability in the mantis's movements. This unpredictability disturbs the snake's internal balance, disrupting its ability to calculate distance and motion. The mantis, designed to act in less than a second, can appear almost supernatural to a creature whose world unfolds more slowly. The snake's retreat is not an admission of weakness, but a strategic withdrawal. Evolution teaches that survival is the preservation of opportunity, not the conquest of challenges. Snakes avoid unnecessary risks, and the mantis represents a risk too small to reward, but too fast to ignore. This interplay enriches the forest's ecology. It shapes the behavior of countless species, creating micro-patterns that influence macro-patterns. The mantis becomes a sculptor of behavior in the early lives of reptiles. The snakes, in turn, contribute to the structure of the insect world by creating selective pressure against slower or less cautious prey. The ecosystem thrives because both groups refine their adaptations, creating a balance where no single trait dominates. Instead, diversity becomes the anchor of stability. In the end, evolution reveals a truth more profound than competition. It shows that life grows through contrast. The praying mantis and the snake represent two versions of survival shaped by different scales, different pressures, and different timelines. Their strengths do not oppose each other. They coexist. Their designs do not conflict. They complement, together. They remind us that the forest is not built by the giants we admire, but by the countless interactions happening in silence, in miniature, hidden beneath layers of leaves where evolution is always at work. Precision in nature is rarely as visible as in the praying mantis. While many predators rely on strength, venom, or brute force, the mantis survives through the mastery of timing and the flawless application of biomechanics. Each part of its body has been sculpted to minimize error. Each movement is a calculated action, and in the micro realm where it reigns, this level of precision becomes a form of dominance unlike any seen in larger species. To understand why even snakes respect the unexpected abilities of this insect, we must examine how it perceives and responds to movement at a scale where milliseconds define life and death. A mantis begins by observing. It does not rush toward prey. It studies the environment with a level of focus rarely matched in the insect world. Its compound eyes, engineered for depth perception, lock onto targets with astonishing clarity. While most insects rely on motion detection alone, the mantis can estimate distance, trajectory, and the probability of success with near-perfect accuracy. This allows it to react not to what is happening, but to what will happen a fraction of a second later. In the dense clutter of the forest floor, such predictive ability offers an unparalleled advantage. Snakes, by contrast, operate on a different sensory plane, their tongues sample chemical signatures drifting in the air. Their bodies interpret vibrations through the substrate. Their heat-sensing pits, if present, allow them to locate warm-blooded prey even in total darkness. These senses make snakes powerful hunters in the macro world, yet they do little to help them decode the lightning-fast decisions of a mantis. A snake's tongue flick provides a snapshot of its surroundings every few seconds. A mantis processes visual information continuously, adjusting its posture and angling its head with micro-rotations that reveal subtle changes in distance and motion. These two sensory systems exist in parallel worlds, one rooted in chemical gradients over large surfaces, the other rooted in rapid optical triangulation. The biomechanics of the mantis's strike are equally astonishing. Its raptorial limbs contain specialized elastic structures that store energy slowly over time. The mantis contracts muscles gradually, building tension without revealing any movement externally. This tension transforms the limbs into biological springs. When released, they unfold so rapidly that the prey has no chance to escape. In physical terms, the strike operates on a time scale so short that it bypasses the typical reaction window of small reptiles. This is why a young snake may recoil when a mantis moves. The speed is beyond what its nervous system can comfortably track, not because the mantis threatens the snake directly, but because the snake instinctively recognizes unpredictability and avoids it. Unlike larger predators that rely on muscle mass, the mantis exploits physics. At small scales, inertia is low. Surfaces grip differently. Air resistance behaves more like a fluid. The mantis has evolved to take advantage of these environmental conditions, using minimal energy to generate maximum acceleration. Its strike is not merely fast, it is efficient. Very little energy is lost. Almost all of it is directed toward the single purpose of capturing prey in one flawless movement. For perspective, if a mantis were scaled to human size while maintaining proportional speed, it would complete a full striking motion faster than the blink of an eye. After the strike, the mantis's mandibles begin their work. These jaws are not designed for crushing bone or tearing flesh, but for disassembling prey methodically. Each segment of its mouth parts performs a different task: cutting, grinding, and guiding the food inward. This efficient system allows the mantis to feed without relying on venom. Its success comes not from overpowering prey, but from denying it any opportunity to escape. This feeding process further emphasizes its evolutionary theme: precision, not force, builds survival. When compared to other predators, the mantis occupies a unique position. Its hunting style differs from that of cats, whose muscles propel them in high arcs toward fleeing prey. It differs from birds of prey, which rely on sharp talons, powerful wings, and acute vision to seize animals at high speeds. It differs from Wolf spiders, whose ambushes depend on stealth and explosive leg power. And it differs from snakes, which strike through coordinated muscular contraction and leverage venom or constriction. The mantis uses none of these tools. Its technique is so specialized that it would be ineffective at larger scales. Yet in the micro world, it is unmatched. The comparison to snakes is especially revealing. A snake strike, while fast, follows a predictable trajectory. It relies on the snake's ability to sense the position of its prey and launch forward with accuracy. But a mantis' strike is less like a forward attack and more like a sudden snapping mechanism. There is almost no warning, no preparatory movement detectable to external observers. A young snake observing a mantis cannot predict when the strike will occur. This unpredictability creates a biological tension that encourages avoidance. The mantis does not need to harm the snake to shape its behavior. Its precision alone becomes a cue of caution. Even adult reptiles display subtle responses to mantis-like motion. When encountering insects with rapid postural changes or unnatural mechanical speed, many reptiles pause, reduce movement, or redirect their path. Such behaviors reveal how deeply speed-based unpredictability influences reptilian decision-making. The mantis, as the pinnacle of this unpredictability, naturally becomes an evolutionary reference point. It represents a category of creature that snakes do not fully understand but instinctively respect. The mantis perceives motion differently from reptiles. Snakes detect movement largely through vibrations and changes in chemical landscapes, while mantises interpret the world visually. Their compound eyes can detect both fine detail and rapid shifts in light patterns. This dual capability allows the mantis to distinguish between harmless environmental movements and meaningful biological signals. A leaf swaying in the wind produces a pattern of motion, too broad and slow to trigger a response. But the twitch of an insect leg, the ripple of a soft-bodied larva, or the cautious advance of a juvenile snake produces highly specific optical changes that the mantis can track with remarkable accuracy. This visual discrimination reduces wasted strikes and makes the mantis one of the most energy-efficient predators in its habitat. In many ways, the praying mantis is a mirror of evolution's fascination with precision. Every function of its body, from its eyes to its forelegs, reflects an ancient pressure to survive in a world where speed defines opportunity. The snake, a creature of stealth and patience, finds in the mantis a counterpart shaped by completely different laws. Their interaction becomes a rare moment where two evolutionary philosophies meet. One prioritizes silent control, the other prioritizes instantaneous release. One reads the world chemically, the other reads it visually. One relies on coiled muscle, the other relies on stored potential energy. These differences highlight the diversity of strategies that life has developed to master the forest. In the end, the mantis's deadly precision is not intended for snakes. It is simply part of the ecosystem, a feature of the micro-world that influences everything around it. Its role extends beyond predation. It becomes a behavioral sculptor, shaping how other species move, sense, and survive. Young snakes, encountering this speed for the first time, internalize the lesson that survival often depends on recognizing unpredictability. The mantis serves as a silent mentor, teaching without intention, guiding without awareness, embodying a version of power defined not by dominance but by design. And through that design, the mantis leaves an imprint on the lives of creatures far larger than itself. In the rainforest, most encounters between a praying mantis and a snake pass unnoticed by human eyes. The mantis remains anchored to its perch, scanning the environment with unwavering focus, while a young snake glides nearby, its body moving like a thin ripple of shadow through the leaf litter. Its instincts respond not with aggression, but with hesitation. The mantis does not move continuously. It moves with precision, shifting posture only when necessary, and freezing instantly when threatened. This pattern confuses the snake's developing senses. Vibrations fade before reaching its body. Chemical cues are minimal. Visual cues shift too quickly to interpret. What remains is uncertainty, and uncertainty in nature often becomes a signal of retreat. The snake lowers its head, slows its movements, or changes direction entirely. It is not fear, it is strategy. The mantis, for its part, rarely acknowledges the snake unless it comes too close. Its world is narrower, defined by the reach of its forelegs and the shadows that fall within striking distance. A snake, even a small one, exists outside this range. The mantis observes only long enough to classify the reptile as irrelevant, then returns to its patient vigil. In its stillness, it shapes the behavior of creatures around it without ever engaging them. This is the quiet influence of precision. The mantis does not dominate the snake. It simply represents a form of unpredictability that the snake instinctively avoids. On rare occasions, when a hatchling snake is small enough and the mantis is large enough, the encounter may turn predatory. But such events are exceptions, not rules. They reflect the overlapping scales of life rather than direct ecological rivalry. The forest is full of mismatched interactions like these, moments where the boundaries between predator and prey blur only because of circumstance. More often, the mantis and the snake coexist peacefully, each following its evolutionary script. What truly shapes their interaction is not conflict but learning. The mantis reinforces the idea that power can exist in small, precise forms, and the forest continues its rhythm, oblivious to the silent exchange taking place beneath its canopy. In these fleeting encounters, we glimpse how evolution weaves connections between species that rarely touch, shaping instincts, behaviors, and the hidden logic of survival. In the vastness of the rainforest, it is tempting to believe that strength belongs to the largest creatures, the predators that dominate entire ecosystems with muscle, venom, or sheer mass. But the encounters between a young snake and a praying mantis expose a deeper truth, one woven into every layer of the natural world. The mantis thrives because its design fits the rules of its world perfectly. The snake thrives because it learns from that world, reshaping its instincts through subtle lessons that carry into adulthood. The mantis does not overpower the snake. It simply embodies a kind of mastery that the snake cannot ignore, a mastery of timing, patience, and movement. This influence ripples outward, shaping behavior across species that never truly interact as rivals. The snake grows cautious not because it fears the mantis, but because the mantis teaches it to respect unpredictability, to recognize that survival depends on acknowledging forces outside one's scale. This is the essence of the forest's intelligence. Every creature contributes to the equilibrium, whether it weighs a few grams or several kilograms. Micropredators like the mantis maintain the balance of insect populations, protect plant life, and indirectly shape the opportunities available to reptiles, birds, and mammals. Their presence stabilizes the system from the ground up, and young snakes, moving through this miniature world during their most vulnerable stage, absorb lessons that prepare them for a life in the broader ecosystem. They learn patience from stillness. They learn caution from speed. They learn that dominance in nature is not granted by birth, but earned through understanding. A young snake, shaped by micro-encounters it barely understands, carries forward the architecture of survival. Power circulates through the forest in forms that defy our expectations. It comes from precision, from adaptation, from relationships that unfold in silence. It is about harmony with the rules of the world one inhabits. The mantis has mastered its scale. The snake grows by navigating between scales. The praying mantis and the young snake remind us that survival is not written by size or strength, but by the quiet wisdom of adaptation. Here, power moves softly, precision replaces force, and the smallest encounters ripple through the forest in ways we rarely see. As we leave this micro-world behind, we carry with us its lesson. Nature's true brilliance lies in the strategies woven into even its tiniest inhabitants. If you wish to explore more of these silent stories and the science that shapes them, continue your journey with us. The forest still has countless secrets waiting to be understood.